In this example, we're going to be graphing f of x is equal to negative 1/2 to the x plus 1 power, then plus 2. So there's a few things here that are going on with this particular equation, but to graph this efficiently, what we're going to do is we're actually going to graph a parent function. And the parent function that we're going to graph is y is equal to 1/2 to the x power. It looks like I'll have to write that a little bit lower here for you. So we'll do y is equal to 1/2 to the x power. To graph that, what we're going to do is we're just going to pick values of x, and we're going to see what happens to y. When x is 0, 1/2 to the 0 power is actually 1, so the y value will be 1. When x is 1, 1/2 to the first power is a half. When x is 2, 1/2 to the second power is actually a half times a half, which is a quarter. And this trend is going to keep going, and our points are going to get closer and closer and closer to the x-axis. If we think about negative x values, for instance, when x is -1, 1/2 to the -1 power is 2, or 2 to the first. 1/2 to the -2 power is 4. So the point -2, 4 is going to be on this parent function graph. Once again, this is not the graph of f of x. This is just going to be a helper graph. And if we take a look at the next point, I can see here that if I move to the left by one x value, it appears that each y value is doubling. So I have 0, 1, -1, 2, and the next y value is 4. So if I move to the left, again, I have to double that y value 4 to get 8. If I want, I can just go ahead and try to connect these dots together. And I don't want to cross over, but I want to get very, very, very close to that x-axis there. So now that we have our parent function, let's go ahead and see if we can graph the graph in blue. We're going to look at our transformations here. So our first transformation is a reflection over the x-axis. That's what the negative sign does. So I'm looking at this piece right here. And then the x plus 1, that's going to be a shift left 1. Remember to do the opposite of that number. And then the plus 2 right here is going to be a shift up 2. Now, when you transform the red graph into the blue graph, I would highly recommend that you do the reflection first, and then we're going to shift every point left 1, up 2. So here's what's going to happen. If I take my anchor point 0, 1 and I reflect it over the x-axis, that point becomes 0, -1. And then I have to go left 1, and then I have to go up 2. And so that anchor point of 0, 1, actually, when we do all those transformations, becomes the point -1, 1. I'll get rid of some of this other stuff there for you. Let's pick -1, 2, and we're going to do the same thing here. So if I reflect -1, 2, that point becomes -1, -2. Then we're going to move left 1, up 2. So I have this point right here. I also know that my asymptote is going to be at plus 2. And right now I'm looking for that asymptote to be right here at y is equal to 2. I'm actually going to write that down here on the left-hand side. So we have y is equal to 2 for our asymptote. So I'll just go ahead and draw that in there. And this will help us to kind of figure out what the graph is going to look like. So if you think about it, if I'm looking at this height right here, this height is 1 from that asymptote. This height is 2. And you guessed it, the next height is actually going to be 4. Now you can also do the transformations. So if we did the transformation piece, then let's see if we can delete some of those. That point needs to stay there. The point -2, 4 would be down here. And then we would have to move that left 1, up 2, so it does become that new point. So there's a few different ways of thinking about graphing these. One way to think about it is the distance from that asymptote. Now, if the distance from the asymptote is 4 here, so that's 4 units all the way to the point, then the next distance is going to be 8 because the base is 1/2. So what we're going to do is we're going to go from that asymptote. So we're going to go from that asymptote down 8 units. That's what the 1/2 is doing with this particular equation. I also know that my y values will be cut in half as I approach that asymptote or get closer to it. So my graph is going to look a little bit like this. So I'll just try my very best, miss that one, try my very best, a little bit better to connect all those points. And I don't want to cross over that asymptote. I just want to try to get closer to it. So that might be a better line right there. Okay. Now we'll go to the key features on the left-hand side. This is definitely decay. The rate at which this is decaying is 1/2. So that's related right here to the base. What you want to do for that is look at the base. If the base is between 0 and 1, it's decay. And then if the base is greater than 1, then it's going to be growth. The domain, which are the possible x values here, those are every real number. Any real number is okay for x. And then the range is going to be related to the y values, or those are the possible y values. So every y value from negative infinity to 2, up to but not including 2, that's why we use a parenthesis there, is possible. The x-intercept happens to be right here. So right here, that's -2, 0. We actually don't have to do any serious math for that one, although we actually could. So what you would want to do in that case, let me scroll down just a bit for you, is you'd want to set the y value equal to 0. And so we can actually, well, I guess we can solve that here real quick. All right, we got +1 here, and then -2. Actually, that is a +2. Strike that. And then we'll subtract 2 from each side. And we'll divide by -1. So those negative signs will be positives. So we'll have 2 is equal to 1/2 to the x plus 1 power. Now you might be wondering how we could do this algebraically, and we're going to pull a little trick here on the 2. We're going to make that 2 1/2 to the -1 power, and that's actually true. So you would flip the inside fraction, and that would be 2 over 1 raised to the first power. And we're now going to set the bases are the same, so we're going to set those exponents equal to each other. So we got this guy right here and this guy, and oops, I'll have to do a little bit of subtraction here. So if we subtract 1 from each side, we find x to be -2. Another way of doing this would be to change the 1/2 into 2 to the -1, which is at this step right here. And then you could distribute the -1 across the x plus 1 and set the exponents equal. That, of course, would be 2 to the first on the left-hand side. Let's continue on with the y-intercept here. So the y-intercept appears to be, and the y-intercept is 0, and I think that's 0 3/2 or 1.5. So what I'm looking at right now here, folks, is this guy right here, not the red one, the blue point. We can also do this algebraically if you really want to. So if we did that algebraically, it would look a little bit like this. So we would do y is equal to the opposite of 1/2 to the 0 plus 1 power. That's +1 here supposed to be. And then +2. So we'll move the screen down a little bit. And we've got the opposite of 1/2. And that would be to the first power +2. So that's -1/2 plus 2. And there's your 3/2 or 1.5 or 1.5. The end behavior for this particular function, as x approaches infinity or goes to the right, we can see that the y value that we approach is actually 2. That's your horizontal asymptote. As we go to the left, the y values approach -infinity. So that would be all the way down right here. Okay?